The United States Armed Forces ranks among the world's largest consumers of ammunition, expending hundreds of millions of rounds annually for training, combat, and marksmanship. With such extensive usage, a critical question emerges: what happens to all the spent rounds? At the same time, countless unused rounds sit in storage, eventually exceeding their shelf life or becoming obsolete. Historically, these munitions were simply discarded or destroyed, leading to environmental concerns and financial burdens. However, over recent years, the US military has introduced a number of innovative processes for the recycling and renovation of ammunition, transforming a potential waste issue into an opportunity for sustainability and cost savings. In this video, we'll take a look at these ammunition recycling and renovation efforts, highlighting the environmental and economic benefits, technological advancements, and the challenges that lie ahead. In the 21st century, munitions recycling and renovation are crucial for environmental and economic reasons. Traditional disposal methods like open burning release harmful pollutants, causing long-term ecological damage. Recycling mitigates these hazards, conserving valuable resources such as brass, lead, and steel, reducing the military's environmental footprint. Economically, restoring old ammunition provides cost-effective rounds, ensuring a steady supply for maintaining combat readiness. This approach not only saves money, but also supports the effectiveness of US forces by providing reliable, affordable ammunition. Before we witness the complexities of refurbishing unused projectiles, let's first take a look at how the US Air Force tackles the recycling of spent ammunition. When it comes to spent rounds, the recycling process varies depending on the size and type of ammunition, and begins with the collection and separation of the spent brass casings from other components, such as the projectiles and gunpowder. These casings, which are often found littering firing ranges and training grounds, are valuable resources that can be reclaimed and repurposed. This process is now in full swing at Joint Base San Antonio's Lackland Air Force Base, thanks to the 502nd Civil Engineer Squadron putting in the hours every month to collect spent casings from 9mm through to 50 caliber rounds, before checking, separating out any live rounds and non-recyclable metals. They then deform the casings before they ship the brass for processing. It's a similar story at the Combat Arms Range for the 914th Air Refueling Wing at Niagara Falls Air Reserve Station. Here they train unit members and facilitate small arms live fire training for local units of the New York Air National Guard, Coast Guard, and Customs and Border Protection, processing approximately 250,000 spent rounds of ammunition each year. The empty rounds are returned to munitions, sorted onto pallets, and then categorized into frangible, ball, and blank ammo. Just as they do at Lackland Air Force Base, they are then transferred to a sorting table where ammo links, debris, and especially any live rounds are removed. Not only brass, but also steel and other metals are collected, with any live rounds that are found being brought back to accountability so that they can be fired again.
Basically what we have here is steel links. Whenever a unit comes in, they usually bring it in their wooden boxes or a metal can. And basically we sort through it to make sure there's no brass or no live ammo in it. And then we put it in this big old hopper. Just steel goes in here, nothing else. And then when it gets full like this, we'll get a forklift and we take it down to the metal dump.
The spent rounds are sealed and certified to state that no live rounds are present. They are then prepped for the deformer, which literally deforms the empty rounds so that they cannot be reloaded into a weapon.
Then we do an inspection process, verify they're all empty. Once we do that, we get them transported down here via forklift. And again, as we're prepping them to get them into the deformer, we again do another quick inspection, make sure there's nothing else live in there. Once that's all set, we go through and as you see, we pour them into the deformer, ensure that everything goes in the slow process so nothing bogs down. And then the end result is what you see here with the deformed brass, and which we turn in to bring money back to the base.
Some military installations have a brass sorting device that can accurately sort more than 5,000 spent rounds per hour. This device not only evaluates whether or not the bullet has been fired, but also identifies different calibers with ease, drastically speeding up the recycling process. Meanwhile, over at the US Army's Joint Munitions Command, or JMC, they have a number of installations and depots where they manage conventional munitions, that is, weapons that use explosive material based on chemical energy, as opposed to nuclear energy in nuclear weapons. JMC is the latest in a series of commands since World War II that manage the United States' vast and complex munitions enterprise, which is spread across the country. Here, conventional munitions are produced, stored, distributed, and demilitarized. JMC also positions munitions around the world to facilitate rapid transition to armed conflict. In fact, every bullet, bomb, and grenade that US warfighters use in training and combat is managed by JMC. Refurbishing ammunition, particularly larger artillery shells, is a complex and meticulous process which also falls within JMC's remit. This process is managed at a number of facilities, such as the McAllister Army Ammunition Plant in Oklahoma. Here, obsolete munitions that have passed their use-by date are transformed into training rounds through an innovative renovation process known as soft touch. This method ensures that key components of the projectile, such as the base plate, nose, and body, are preserved during handling. By maintaining the integrity of these components, the military can maximize their reuse and produce shells that cost much less than new ammunition. One notable example is the transformation of obsolete D563 projectiles into M1122 training rounds. These projectiles, which had exceeded their 20-year storage shelf life, were salvaged and demilitarized. Their components were then repurposed to create the M1122 rounds, which closely mimic the ballistics and performance of actual combat rounds. This not only provides soldiers with realistic training experiences, but also ensures that the military can allocate resources more efficiently. At the same time, over at the Bluegrass Army Depot in Richmond, Kentucky, they are also working on 155mm munitions. But rather than transforming old shells into training rounds, they are busy renovating shells for frontline use in systems like the M777 howitzer and the M109 self-propelled howitzer. The process begins with a thorough inspection of each shell to assess its condition. If they are not suitable for renovation, they are sent for decontamination and destruction, along with any other excess, outdated and inoperable ammunition that is no longer fit for purpose. If the shell is deemed suitable for reuse, it undergoes a series of steps to restore it to operational standards. This includes sandblasting the shell body to remove any rust or old paint, followed by repainting it according to military specifications. The importance of this step cannot be overstated. The different colours and markings of the shell provide vital information, such as the type of munition, lot number, and the date of production. These details are essential for inventory management and to ensure that the right munitions are used in the right scenarios. The impact of these efforts is substantial, with the renovation program estimated to save the military hundreds of millions of dollars every year. The entire process not only saves money by extending the life of existing munitions, but also reduces the environmental impact by decreasing the need for production of new shells. Through this collaboration, the Army has been able to meet the increased demand for 155mm shells, particularly in light of the ongoing conflict in Ukraine. This partnership has not only ensured a steady supply of ammunition, but has also fostered innovation and efficiency in both the production and supply process. Despite the successes, the recycling and renovation of ammunition is not without challenges, one of which is the handling of hazardous materials. Ammunition contains components like lead and explosives, which require careful handling and disposal. Ensuring the safety of personnel involved in these processes is paramount. To this end, advanced robotics are increasingly being used to disassemble ammunition safely. These robots can handle hazardous components with precision, reducing the risk of accidents and ensuring that materials are processed in the safest possible manner. Another challenge is the need for continuous innovation. As new types of ammunition are developed, recycling and refurbishing techniques must evolve to keep pace. This requires ongoing research and investment in new technologies, as well as training for personnel to handle the latest advancements. According to a 2018 report from the US Department of Defense Inspector General, As of September 30, 2016, a staggering 471,767 tons of military assets awaited demilitarization. The military's approach to recycling and refurbishing ammunition is therefore a positive step, showing a commitment to resource efficiency and sustainability. However, these efforts are just a small part of the military's larger environmental footprint, with extensive use of helicopters, tanks, ships, and jets, to name but a few. The US military remains one of the world's largest energy consumers, contributing significantly to global emissions. Real sustainability will require deeper reforms across all defence operations, from fuel usage to adopting greener technologies. And so, while these current efforts are positive, they should be seen as one of the first steps in a much longer journey towards real environmental sustainability.